Following significant advances in digital audio technology during the 1970s, it rapidly replaced analog audio technology in most areas of sound production, sound engineering and telecommunications. A microphone converts sound to an analog electrical signal, then an analog to digital converter, typically using pulse code modulation, converts the analog signal into a digital signal. A digital to analog converter performs the reverse process, converting a digital signal back into an analog signal, which analog circuits amplify and send to a loudspeaker. Digital audio systems may include compression, storage, processing and transmission components. Conversion to a digital format allows convenient manipulation, storage, transmission and retrieval of an audio signal. Overview of digital audio. Digital audio is useful in the recording, manipulation, mass production, and distribution of sound. Modern online music distribution depends on digital recording and data compression. The availability of music as data files, rather than as physical objects, has significantly reduced the cost of distribution. An analog audio system captures sounds and converts their physical waveforms into electrical representations of those waveforms by use of a transducer, such as a microphone. The sounds are then stored, as on tape, or transmitted. The process is reversed for playback. The audio signal is amplified and then converted back into physical waveforms via a loudspeaker. Analog audio retains its fundamental wave-like characteristics throughout its storage, transformation, duplication, and amplification. Analog audio signals are susceptible to noise and distortion, due to the innate characteristics of electronic circuits and associated devices. Disturbances in a digital system do not result in error unless the disturbance is so large as to result in a symbol being misinterpreted as another symbol or disturb the sequence of symbols. It is therefore generally possible to have an entirely error-free digital audio system in which no noise or distortion is introduced between conversion to digital format and conversion back to analog. A digital audio signal may be encoded for correction of any errors that might occur in the storage or transmission of the signal, but this is not strictly part of the digital audio process. This technique, known as channel coding, is essential for broadcast or recorded digital systems to maintain bit accuracy. The discrete time and level of the binary signal allow a decoder to recreate the analog signal upon replay. 8 to 14-bit modulation is a channel code used in the audio compact disc conversion process. A digital audio system starts with an ADC that converts an analog signal to a digital signal. The ADC runs at a specified sampling rate and converts at a known bit resolution. CD audio, for example, has a sampling rate of 44.1 kHz, and has 16-bit resolution for each stereo channel. Analog signals that have not already been band limited must be passed through an anti-aliasing filter before conversion, to prevent the distortion that is caused by audio signals with frequencies higher than the Nyquist frequency, which is half of the system's sampling rate. A digital audio signal may be stored or transmitted. Digital audio can be stored on a CD, a digital audio player, a hard drive, a USB flash drive, or any other digital data storage device. The digital signal may then be altered through digital signal processing, where it may be filtered or have effects applied. Audio data compression techniques, such as MP3, advanced audio coding, Ogg-Vorbis, or FLAC, are commonly employed to reduce the file size. Digital audio can be streamed to other devices. For playback, digital audio must be converted back to an analog signal with a DAC. DACs run at a specific sampling rate and bit resolution, but may use oversampling, upsampling or downsampling to convert signals that have been encoded with a different sampling rate. History of digital audio use in commercial recording. Pulse code modulation was invented by British scientist Alec Reeves in 1937 and was used in telecommunications applications long before its first use in commercial broadcast and recording. Commercial digital recording was pioneered in Japan by NHK and Nippon Columbia, also known as Denon, in the 1960s. The first commercial digital recordings were released in 1971. The BBC also began to experiment with digital audio in the 1960s. By the early 1970s it had developed a two-channel recorder, and in 1972 it deployed a digital audio transmission system that linked their broadcast center to their remote transmitters. The first 16-bit PCM recording in the United States was made by Thomas Stockham at the Santa Fe Opera in 1976, on a SoundStream recorder. An improved version of the SoundStream system was used to produce several classical recordings by Telarc in 1978. The 3M digital multitrack recorder in development at the time was based on BBC technology. The first all-digital album recorded on this machine was Ry Cooder's Bop Till You Drop in 1979. British record label Decca began development of its own two-track digital audio recorders in 1978 and released the first European digital recording in 1979. Popular digital multitrack recorders produced by Sony and Mitsubishi in the early 1980s helped to bring about digital recordings acceptance by the major record companies. The 1982 introduction of the CD popularized digital audio with consumers. Digital audio technologies. Digital audio broadcasting, HD radio, digital radio mondial, in-band on-channel, storage technologies, digital audio player, digital audio tape, digital compact cassette, compact disc, hard disk recorder, DVD audio, mini disc, super audio CD, Blu-ray disc, various audio file formats. Digital audio interfaces. Audio-specific interfaces include AC 97 interface between integrated circuits on PC motherboards. Intel U high-definition audio, a modern replacement for AC 97. ADAT interface. AES-3 interface with XLR connectors. AES-47, professional AES-3 style digital audio over asynchronous transfer mode networks. I2S interface between integrated circuits and consumer electronics. MADI multi-channel audio digital interface. MIDI low bandwidth interconnect for carrying instrument data, cannot carry sound but can carry digital sample data in non-real time. SPDIF, either over coaxial cable or toslink. TDIF, Tascam proprietary format with D-sub cable. A2DP via Bluetooth. Naturally, any digital bus can carry digital audio. Also, several interfaces are engineered to carry digital video and audio together, including HDMI and DisplayPort. In professional architectural or installation applications, many digital audio networking protocols and interfaces exist.